So hello everyone again. This is lecture number 8 from motion in a plane. So in the last discussion, we started with the concept regarding uniform circular motion, in which we were trying to understand about acceleration. We will begin with the further discussion regarding that topic only, and then end this chapter. So this will be the last lecture of motion in a plane. So let's start our discussion directly. So I'm Samir Lawankar. Let's begin our discussion about lecture 8 for motion in a plane. Okay, so right now we're on the 11th topic, that is uniform circular motion. So we started with the introduction, then scalars and vectors, as in the difference between scalars and vectors. Then next thing is which we understood about multiplication of vectors by real numbers, which was one of the property for vectors. Then we understood graphical method. In the previous discussion only we understood what was the basic application of subtraction of vectors when we were trying to find out the direction of delta v, correct? Then next was the resolution of vectors, in which one vector a can be resolved into two components, let us say ax I cap and ay j cap, correct? Next thing was about vector addition, analytical method, in which we calculated r, which is equal to a square plus b square plus 2ab cos theta, correct? Then we understood about motion in a plane. Then next thing was about motion in a plane with constant acceleration, in which we derived three formulas or three kinematic equations. First was v is equal to v naught plus at. Second was s or not s, let us say r only. R is equal to r naught plus v naught t plus half at square. And the third was v square is equal to v naught square plus 2 into a into v minus r minus r. Okay, so these were the equations which we derived here. And the relative velocity concept, we just understood that VAB is equal to VA minus VB. So only the case changes that in the previous case in motion in a straight line, we understood it in one dimension. Here the velocity is basically in two dimensions. So this can be said in components also. And hence it can be something like this, that VXAB is nothing but equal to VXA minus VXB. And similarly VYAB is equal to VYA minus VYB. Okay. Then in the last lecture, we have completed the uniform circular motion, in which we understood first of all equation, then height, then time, mid time, that is my time to maximum height, then time of flight, and then range. And we solved the questions regarding this also. And in the last lecture, at the last 10 minutes, we started with the uniform circular motion. So let us start discussing about uniform circular motion only directly, and then we can move forward, look at the summary, and then close this lecture and basically this chapter. Okay, so let's start our uniform circular motion again. So these all things are understood in the last lecture only. So just a quick revision here. So finally what we got is that the direction of delta v is in this direction, that is delta v. Okay, so here since the path is circular, v is perpendicular to r, and so v dash is to r dash. Therefore, delta v is perpendicular delta r. Okay. Now, since average acceleration is along delta v, so you know why is the average acceleration of delta v? Because a bar is equal to delta v by delta t. Because delta t is a scalar, so we can just know that if there is a vector a bar, it will be some multiplication factor of delta v, 1 upon t, delta t into v, delta v bar. So only direction will be same, only the magnitude will change. That is why the average acceleration is along delta v. And because delta v is perpendicular to delta r, therefore the average acceleration is also perpendicular to delta. So I hope this line is clear to you. So the final summary is that the average acceleration a bar is perpendicular to delta r. Fine. Now, if we place this delta v on the line, on the line that bisects the angle between r and r dash. So let us say they are saying that if we keep it on this bisector line. Okay, so if we keep this on the bisector line, and we see that it is directed towards the center of the circle. Okay, so if we keep it at this position, you can see that where it is directing upon, it is directing towards the center of the circle, right? So it is just one of the fact which is written here, one of the discussion which is to be made. So finally, what is the final conclusion? First thing is this, and second thing is that if we place delta V here, then we can obtain it is directed towards the center of the circle. Okay, let us move forward. Now figure B shows the same quantity for smaller time interval. So now only delta T is being reduced. So delta T is being reduced, then the amount of delta R will also reduce. Right? Delta R will also reduce because it requires less time. If less time is given, then the movement will also be less only. Correct? So therefore now again we did the same thing here and found that delta V is being approaching this direction, which is towards the center of the circle. The figure V shows the same quantities for smaller time interval. Now delta V bar and hence A bar, because we know that delta V and A both are towards the same direction. So delta V and hence A bar is directed towards the center. Same discussion again here, which is being propagated in the previous slide. Only the change is that this time again, only the change is that the displacement is being reduced. Okay, fine. Next thing is in figure C, delta T tends to 0. So in figure C, in this location, what we are seeing, a delta T is tending to 0. So what will happen here? The average acceleration, first of all, becomes the instantaneous acceleration. So the complete concept of why average acceleration becomes the instantaneous acceleration is being dealt in the previous slides only, in the previous discussion, when we were understanding the subtopic motion in the plane. And in this, when we were understanding the acceleration part, correct? So you may just look back and watch those lectures so that you can understand why we did, why is average acceleration becoming instantaneous acceleration when density tends to 0. Okay, so again it is directed towards the center. So as you can see that this acceleration is directed towards the center. Okay, thus we find that the acceleration of an object in uniform circular motion is always directed towards the center of the circle. Okay, so hence this thing can be explained here quite clearly. This is one of the summary which you obtained, that what is the acceleration of an object doing? It is always directed towards the center of the circle. Okay, fine. So that thing being said, let us now find the magnitude of acceleration. So till this point we obtained a direction. The direction is being obtained. Correct? Now we are trying to find out the magnitude. So what is the magnitude? Okay, so we will obtain that it is a constant magnitude only, but let us try to find it. Okay, fine. So now the magnitude of A is therefore by definition given by what? So we know that if you're talking about some time interval delta T, then the acceleration value is nothing but equal to delta V by delta T. Correct? Now if we are trying to find out the limit when delta T tends to 0, then this average acceleration becomes instantaneous acceleration, and therefore this acceleration is nothing but equal to limit delta T tends to 0 delta V by delta. Okay, so we are trying to find out the mod. It's nothing but mod A is equal to limit delta T tends to 0 mod of delta V by delta, and that is only been written. Okay, so the magnitude of A is therefore in definition given by del V by del T, limit delta T tends to 0. Now let us do some mathematical expressions here and let us try to find out its value. So let the angle between the position vector R and R dash be delta theta. So this is, let us suppose this is the angle delta theta been explained here. Okay. Now since the velocity vector V and V dash are always perpendicular to the position vectors, so that means that the angle between them will also be delta theta. That means we can understand this angle to be also equal to delta theta. Okay. Therefore, the triangle CPP dash. So where is angle CPP dash? This is the triangle CPP dash. Okay. So the triangle CPP dash formed by the position vectors and the triangle GHI. So if I just go back, I can actually, okay, so this is the triangle GHI being formed here. Okay, so this is the triangle GHI being formed here, and this is the triangle CPP dash. Okay, so this is your GHI. Okay, so therefore the triangle CPP dash formed by the position vectors and the triangle GHI formed by the velocity vector V dash and delta V are similar. Okay, so you have understood. So you have understood the similarity of triangle concept in your 10th class only. So that thing is correctly applied here. Therefore, the ratio of the base length to side length for one of the triangles is equal to that of the other triangle. So they are just saying that these two triangles are similar. Okay. So therefore, the ratio of base length to side length for one of the triangles is equal to that of the other triangle. So therefore, what you obtain is that the value of delta V upon any value. So let us say if we are talking about if this is delta R, let us suppose, sorry, this is delta R, this is delta V. Let us say this is V and this is R. So what we can write? We can write mod of delta V upon mod of delta R is equal to V by R. Just doing cross multiplication, you will get mod of delta V upon V is equal to mod of delta R upon R. So they are just writing this small r as capital R. Okay. So I did nothing new here. I am just applying the basic equations of your mathematics. Similarity of triangles is being applied. Okay. So similarity of triangles lead us to delta V. So what is the mod of delta V? Mod of delta V is equal to V by R delta R. Okay. Fine. Moving on. Therefore, what is mod A? Mod A is nothing but equal to, so in the place of delta V, we will substitute it here. Okay. Let us try to substitute. We know mod A is nothing but equal to limit delta T tends to 0 mod of delta V by delta T. Right? We know what is mod of delta V? Mod of delta V is nothing but equal to small v by capital R into mod of delta R. Just have to put it here. So this will be equal to limit delta T tends to 0 V by R into delta mod R by delta T. Correct? As V and R are constants, correct? Velocity will also be constant and capital R will always be constant. Okay? We can put it outwards. The velocity doesn't have any effect on time, correct? But velocity is constant here at a particular position. Limit delta T tending to 0 mod of delta R by delta T. Correct? Now what is this? If you see this clearly, what is this? This is basically a change in velocity, change in displacement with respect to time. So this is basically nothing but your velocity only, right? So hence the magnitude which we obtained is equal to v square upon r. Okay, so this is the magnitude of the uniform circular motion, and in which direction it is directed upon? It is directed upon the direction which is towards the center of the circle. Okay. So before going forward, let me just iterate everything which is written here. Therefore, mod A is equal to limit delta T tending to 0 mod delta V by delta T. Just putting this equation, this equation here, that is mod of delta V. Using this two equations, we can just substitute this here. You can get mod of delta V nothing but V by R into delta R. Hence, average acceleration will give you expression which is V by R into mod delta R by delta T. V by R can be put away from the outwards of the limit value, and you will get equal to V by R into limit delta T tending to 0 del R by del T. Okay. Moving forward. Now, if delta T is small, delta theta will also be small, and hence the arc PP dash. This is the arc PP dash, can be approximately taken to be mod delta. Okay, so this, because when this value of delta theta is very, very small, and so basically, if I just zoom in and tell you, So basically, when you try to decrease the value of delta theta, this value will keep on reducing to such an extent that it is very, very small. And hence what we can say that this length and this length, and this length, both are approximately same. And that has only been explained. Okay. So hence what we can say that mod delta R is nothing but equal to V delta T. Hence mod delta R by delta T is approximately equal to V, or limit delta T tending to 0 mod delta R by delta T is V. So either you can see it in this fashion, or you can just directly say that this is the thing which you obtained for, and hence for infinitesimally small value of delta T, mod delta R by delta T is nothing but equal to velocity. Okay, so either you can use calculus or either you can use graphical method of understanding it depending on the figure. Okay. Therefore, a new term has been written here: centripetal acceleration. Centripetal is basically a term which is used to say that anything which is towards the center. Okay, centripetal. So therefore, this acceleration is called a centripetal acceleration, and the value of acceleration or the direction, the magnitude of this acceleration is V by R into V, which is equal to V square by R. Okay, that is how you can conclude this complete discussion regarding the magnitude and acceleration of your magnitude and direction of your acceleration. Just write it again. So I'm writing, so direction is V square by R, direction towards the center. Okay, so that's how you can end this discussion here. Let's move forward. Okay, so now thus the acceleration of an object moving with speed V in a circle of radius R has a magnitude V square upon R and is always directed towards the center. Okay, so we just understood this complete concept here. That is why so it is moving with speed V. Please remember, speed V is written, not a velocity V. It is moving with a speed V in a circle of radius R and has a magnitude V square upon R and is always directed towards the center. Okay, this is why the acceleration is called a centripetal acceleration. Okay, a term proposed by Newton. A thorough analysis of centripetal acceleration was first published in 1673 by the Dutch scientist Christian Huygens, but it was probably known to be Newton also some years later. So that's just a fact written here. So what is basically meaning of centripetal? So centripetal comes from a Greek term which means center seeking. So going toward a center or trying to seek center. Okay, so it wants center. So since small b and capital R are constant, the magnitude of centripetal acceleration is also constant. So what is written here? So we know what is AC. AC is nothing but V square upon R. As the value of V, that is the magnitude of V is constant, and the value of radius in which the uniform circular motion will happen is also constant. Therefore, AC value is always constant. Magnitude wise, it is constant. Okay. So the magnitude of the centripetal acceleration is also constant. However, direction changes. Okay, so let us say we are in this circle. So in this direction, in this place, what will be the direction? Like this. In this place, it will be 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 like this. So it basically depends. Okay, so that only the thing which we need to convey, I need to convey here is that AC is a vector here, which is having a constant magnitude but a varying direction. And what is direction? It is always towards the center. Fine. Therefore, a centripetal acceleration is not a constant vector. Yes, it is very important line. A centripetal acceleration is not a constant vector. Only the magnitude of the centripetal acceleration is constant. Okay. So we have another way of describing the velocity and the acceleration of an object in uniform circular motion. So let us try to find this way. So as the object moves from some P to P dash in some time delta t, the line CP turns through an angle delta theta as shown in the figure. So that was some delta theta. This was some delta theta which was being obtained in the previous diagrams. If you see clearly here. So this is your delta theta. This delta theta is called as angular distance. Okay. We now define the angular speed omega. So basically till now, one thing is derived, that centripetal acceleration is nothing but equal to v square by r. Okay, now we will try to derive, or we will try to find a new concept called as angular speed and try to find a relation between the centripetal acceleration and omega. So we define the angular speed. So what we understood till now, what is delta theta? That is the angular distance. What is the angle distance? The amount of angle which the from which it is traveled, the point the object is traversed when it moves from P to P dash. Okay. So we define the angular speed omega as the time rate of, please refer to this definition. Omega is nothing but time rate of change of angular displacement. Okay. This was the angular distance, angular displacement. So therefore what we can write, omega is nothing but equal to change in delta theta, change in theta to change in time. Okay. Now let us try to obtain the result, that is the relation between omega and acceleration. So now if the distance traveled by the object during the time delta t is delta s, let us suppose that this is the time, this is the distance traveled. Okay. Then tp dash is delta s, quite evident. As you can see, this value will be delta s. Then what we can write? We can write v is nothing but equal to delta s by delta t. Very clear. But we know that this value of delta s is nothing but r delta theta. Achha, so how it is the r delta theta? We have, if you remember the initial assumptions of the arc of a circle in mathematics, we know that the arc length, this arc length is nothing but equal to radius into theta, which is an angle traverse, correct? But this is only and only valid for in radians. Okay, so when the theta is in radian, this is valid. So here we are working with one of the assumption that the value of delta s here and the actual traversed location is same. We are assuming this delta s to be equal to r. When it can be assumed? It can only be assumed when the value of delta t is very, very small. Okay. So this thing is okay. Then we obtain that delta is nothing but r delta theta. So we obtain this. So from this we can get delta s by delta t is equal to r delta theta by delta t. So we know r delta theta is nothing but r omega. So therefore we obtain a new result, that is v is equal to r omega. Please remember this because this will be used in several examples, several concepts in the future. Okay. So a chapter completely is devoted to this topic, that is rotation. So there the concept of omega, this acceleration, centripetal, centrifugal forces acting at different locations will be understood in very, very great detail. So let's try to understand this complete concept very clearly. Okay. So a complete chapter regarding these concepts. Fine. So let's not go into that discussion right now. Moving on. So we can express centripetal acceleration AC in terms of angular speed. How we can refer to this? So we know AC is nothing but equal to V square upon R. In the place of V square, what we can write? We can write R omega whole squared upon R. So this is nothing but equal to omega square R square upon R. R are getting cancelled. Therefore, we get AC is equal to V square upon R is equal to omega square R. So that's how we can finally derive this situation. Okay, so AC is nothing but equal to V square upon R, which is equal to omega square R. Okay. So just let me iterate everything again. So this thing is complete, this thing is complete. So we can express centripetal acceleration AC in terms of angular speed. How? So AC is nothing but equal to V square by R. So this is V square here, okay? Which is equal to omega square R square by R, which is equal to omega square R. And finally we got AC is equal to omega square R. So we found the relation between centripetal acceleration and omega. Now more explanation regarding these. The time taken by an object to make one revolution is known as a time period t. So what they are saying, let us say the object started from this location. It started at some time t is equal to 0. Then it went in a circular motion and finally reached at this location again. The time required for this complete one revolution to make is nothing but called as your time p. Okay, which is denoted by capital T, and the number of revolutions made in 1 second called as frequency. Okay, so how to obtain the frequency? Frequency is nothing but frequency is nothing but equal to 1 by T. Okay, so that is how you can obtain the number of revolutions made in 1 second, which is called as frequency. Frequency is always inverse to time period. Okay. However, during this time, the distance moved by the object is how much? S is equal to pi r, that is circumference. Okay, so circumference, that is the time, that is the distance traversed during this time period, capital T. Therefore, what we can write? We can write that V is nothing but equal to distance upon time. So it's distance upon time, or also we can write 2 pi r nu. Okay, so there may be a confusion between this and this. So this is basically your velocity and this is basically your frequency. Okay, so don't get confused regarding this. So one of the way in which you won't get confused regarding this, you can generally write the velocity like this and you can write the frequency like this. So that's how you can understand both these concepts. Okay, so finally what we got, that what is velocity? Velocity is nothing but 2 pi r nu. Okay, in terms of frequency nu, what we have, first of all we have that velocity is nothing but equal to 2 pi r nu. Now we know what is V. V is basically r omega, correct? So 2 pi r nu, correct? So if we just remove r, what we'll get? Omega is nothing but equal to 2 pi nu, which is being obtained here, correct? Now using all these relations again, what we can obtain? We can obtain the value of acceleration, which is nothing but equal to V square upon r. What is value of V? It is 2 pi r nu whole square by r. So it is equal to 4 pi square. R square by r will give you r only. Nu square r. So that is the acceleration value of your what is it? This is the acceleration value for your but in terms of frequency. Okay, fine. So now let us try to understand one of the examples here, and that will be the complete end. Then we'll do the summary, we'll do the complete analysis again, and that will be the end of this lecture series on motion in a plane. Okay, so let us try to understand this example again, example once. Okay, so an insect trapped in a circular group of radius 12 centimeter. Okay, so whatever is given in the question, I will try to write it here. So R is given to you as 12 centimeters. Moves along the groove steadily. Okay, that means it is undergoing uniform circular motion and completes 7 revolutions in 100 seconds. Okay, so 7 revolutions in 100 seconds. Okay, that means what is the time period basically? Time period for one revolution is basically 100 divided by 7. So that much time it takes for completing one revolution. Okay, so therefore what will be the frequency? Frequency will be 1 by T, which is 7 by 100. Okay, hertz. Okay. Next thing is the question for first question which is asked is what is the angular speed and the linear speed of the motion? Okay, so how to calculate these all scenarios here? So first of all, as you can refer to this, you obtained what is omega value. Omega value is nothing but 2 pi nu. Okay, so omega is nothing but equal to 2 pi nu, or we can write as 2 pi by T, right? The first thing is omega value, so we know it is nothing but 2 into, in the place of pi we can write it as equal to 3.14 upon T. What is T? T is nothing but equal to 100 by 7. Okay, so just calculate it. After calculating, you will get the value of omega as equal to 0.44 radians per second. Please remember, try to find out the answer. The unit of omega which is being used is radians per second. Okay, fine. So that thing being said, we now know the value of omega. Now, what is the linear speed? We know what is the value formula for velocity. Try writing velocity with this sign and try writing velocity frequency with this sign, so as to reduce all the confusions regarding these two representations. Okay, so what is velocity? Velocity is nothing but equal to r omega. Okay, so what is the value of r? R is nothing but 12 into omega. Omega is nothing but 0.44. Just multiply it, you will get the answer as 5.3. What will be the unit? Because the unit of radius was in centimeters, therefore the rate velocity will also be in centimeters. So velocity is nothing but equal to 5.3 centimeter per second, and previously we obtained the value of omega as 0.44 radians per second. Fine. So that thing being said, we obtained the first question, that is what is the angular speed and the linear speed of the motion. Okay. Now second part says that, is the acceleration vector a constant vector? What is its magnitude? Okay. So even without saying also we can understand that acceleration vector is not a constant vector. It only has a constant magnitude. Okay. So direction of the velocity v is along a tangent to the circle at every point. Quite evident. Let us say if this is the position, so particle insect motion. So at each of these locations, let's say if you need to calculate the direction of velocity, it will always be tangent to its path. That is how this thing is to be understood. Okay, so direction of velocity v is along a tangent to the circle at every point. So even if we do for these remaining points also, it will always be tangential. Okay. So the acceleration is directed towards the center of the circle. Okay. This thing again we know that acceleration is always towards the center of the circle. Since this direction changes continuously, as you can see, the direction changing continuously, the acceleration here is not a constant vector. So the discussion which we just held in the previous everything is again explained here. So finally what we obtain is, yes, that direction changes continuously, and hence acceleration not a constant vector. But yes, the magnitude of this acceleration will be constant. Okay. So however, the magnitude of acceleration is constant, and therefore what is A? A is nothing but equal to omega square r. Or also we can do it by v square by r. Therefore just putting the values, so it's A is nothing but equal to omega square r, which is equal to 0.44 squared into radius, which is 12. Therefore, as radius was in unit of 12 in centimeters, therefore the answer is obtained in centimeter per second. And hence this is the magnitude of the acceleration, which is equal to 2.3 centimeter per second. Okay. So that thing being said, that's the end of this example, and hence the end of the motion in a plane concept. Okay, so all the concepts which were being important or which were according to the NCERT syllabus being completed in detail. And now let us look at the summary, and then we can close this lecture series on motion in a plane. Okay, so let's start the final summary. Okay. So scalar quantities are quantities with magnitudes only. So that is the first expression which you understood. Okay, so scalars are only those quantities which are having magnitudes. What are the examples of these scalars? The first is the distance, second is speed, third is mass, fourth is temperature. So basically you can add a distance to a distance directly, you can add a speed to a speed, you can add a mass to a mass, you can add temperature to a temperature. Basically all those expressions do not require vector addition, vector multiplication. Okay, so anything of sort of under root of a square plus b square plus 2ab b square, some sort of that would be applied. Okay, so speed, the speed subtraction is being used in relative velocity. So that all thing can be done. Relative speed if you need to calculate, so that all thing can be done directly. Okay. Second thing is the vector quantity of quantities with magnitude and direction both. Okay, what are the examples? The first is displacement, velocity, and acceleration. They obey special rules of vector algebra, which was the basic consideration which we tried to understand in this complete lecture, introductory of this lecture. Okay, of this complete lecture series. A vector A, so this is the third point, which was one of the property, which was one of the subtopic of your understanding of vectors. So vector A multiplied by a real number is also a vector. So some vector B would be formed here, which is nothing but lambda times A bar. Okay. Whose magnitude is lambda times the magnitude of vector A, and whose direction is the same or opposite depending upon whether A is positive or negative. Okay. two vectors A and B may be added graphically using head-to-tail method or parallelogram method. Okay, so what is basically head-to-tail method? Let us suppose this is your A and this is your B. So how is head-to-tail method being worked upon? We will just keep the vector B at this location like this and just give the resultant like this. And if we need to do the same thing for your, let us say, a parallelogram vector addition, so this will be the result. Okay, so that's how you do the analysis for your head-to-tail method and parallelogram. Direction here may change. I'm not doing it up to scale, but at the actual position, the resultant will be some sort of this. Okay, fine. So parallelogram method. So there's one more method which is triangle law of addition, correct? In which we use triangle law of addition. This is a head-to-tail method, nothing but triangle law of addition. Okay. Next thing is vector addition commutative, that is A plus B is equal to B plus A. It also is associative, that is in brackets A plus B plus C is nothing but equal to A plus in brackets B plus C. And we understood about position vector, displacement vector, and therefore we also understood two different types of vectors called as zero vector, null vector, or an unit vector. Okay, so what was basically null vector? A null or zero vector is a vector with zero magnitude. Since the magnitude is zero, we don't have to specify its direction. So direction is there, but we cannot specify direction, or we don't have to specify the direction. Okay, so it has zero. It has the properties. So A plus 0, so basically a vector A when added with a zero vector gives you the same vector. Lambda times O, so when it is multiplied by something, it gives the same vector again. And 0 multiplied by vector A gives you 0. So 0 here is not, it's a simple scalar only. So when 0 is multiplied by it gives you a 0. Next thing is the subtraction of vectors B and A is defined as the sum of A and minus B. So therefore A minus B can be written as equal to nothing but A plus minus B. Okay. Next thing is a vector A can be resolved into components along two given vectors small a and small b lying on the same plane. Therefore, what we can write, let us say this is the vector A we are talking about, and let us say this is small a and this is the small b. So we can write A bar is nothing but lambda times A bar plus mu times B. Okay, and lambda and mu are real numbers. A unit vector associated with vector A has the magnitude 1. Okay, so unit vector always has magnitude 1. How can we obtain the unit vector regarding that direction? So we can write it as n cap, which is nothing but equal to vector A upon mod of. Okay, the direction of this will be same as that of A. Okay, so unit vector associated with the vector A has a magnitude 1 and is along the vector A. So this is the unit vector in totality. Okay, the unit vectors I cap, j cap, and k cap are vectors of unit magnitude. Unit means 1. And point in the direction of x, y, and z axis, respectively, in a right-handed coordinate system. Okay, respectively in a right-handed coordinate system is basically your x, y, z axis. So this is how it is being made. So this is x, this is y, and this is your z. Okay. Next thing is a vector A can be expressed as, so this is nothing but resolving of vectors in I and j. So A is nothing but equal to ax I cap plus ay j cap, where ax and ay are its components along the x and y axis. If the vector A makes an angle theta with the x-axis, so if the vector A makes an angle theta with the x-axis, then this is your ax and this is your ay, right? So simple trigonometric equation, trigonometric formulas gives you ax is nothing but equal to a cos theta and ay is equal to a sin theta, correct? Similarly, if we know the value of ax and ay, then we can obtain the magnitude of A as equal to under root of ax square plus ay square, and tan theta is equal to ay upon ax. Next thing is, now we are understanding motion in a plane topic here. So vectors can be conveniently added using analytical method. So if sum of two vectors A and B lie in the same plane, then R can be written as nothing but equal to Rx I cap plus Ry j cap. Okay, then what will be Rx? Rx will be nothing but equal to Ax plus Bx and similarly ry will be ay plus by. Okay. Next thing, the position vector of an object in xy plane can be written as, so this is again, so basically when what the thing which you want for motion in a straight line, we are just trying to plot the dimension, and now we use vector in vector notation. We can write it as r is equal to xi cap plus yj cap. And how does displacement be obtained? It is nothing but delta r, that is r dash minus r. So just put the values here and you will obtain it is equal to delta xi cap plus delta yj cap. Next, if an object undergoes a displacement delta r in time delta t, and what is its average velocity? Average velocity is nothing but v bar, which is equal to delta r by delta t. The velocity of an object at time t is the limiting value of the average velocity. Please remember, if you need to calculate the value of instantaneous velocity. So the velocity of an object at time t is the limiting value of the average velocity as delta t tends to 0. Therefore, what is v bar? V bar is nothing but, or v is nothing but limit delta r by delta t when delta t tends to 0. How can we write it? We can also write it as differential coefficient of r with respect to t. Now in unit vector, how can it be written? We written as v bar is equal to vxi cap plus v by j cap plus vz cap, where vx is dx by dt, vy is dy by dt, and vz is z by dt. When position of an object is plotted on a coordinate system, v bar is always tangent to the curve representing the path of the object. Okay, so when the position of an object on a coordinate system, v bar is always tangent to the curve. This expression was obtained. This complete methodology was being explained when we understood motion in the plane subtopic. Okay, representing the path of the object. Okay. Next thing, in the similar case scenario, we can work for your average acceleration also and the instantaneous acceleration also. If the velocity of an object changes from v to v bar in time delta t, then its average acceleration is given by a bar is equal to v bar minus v minus v dash by delta t, which is equal to v by delta t. Next thing is, I think it should be v dash minus v and not this. Okay, so this is a little mistake here. It's v dash minus v. So the acceleration a at any time t is the limiting value of a bar as the time interval approaches 0. Because it's final minus initial now. As it is moving from v to v dash. So final will be v dash, initial will be v. Okay. So the acceleration a at any time t is the limiting value of a bar as the time interval approaches 0. So similar case gives you a is nothing but equal to limit delta t tending to 0 del v by del t, which is equal to dv by dt. So in component form, how we can write it? We can write it as a is equal to axi cap plus ayj cap plus azk cap, where ax is dvx by dt, ay is dv by dt, and az is dvz by dt. Now, if an object is moving in a plane with constant acceleration, that is a is equal to mod a, which is equal to under root of ax square plus ay square, then its position vector at time t is equal to 0 is r0. Then at any time t, it will be at a point. How we can write it? So now it is basically kinematics equation which are being derived here. Okay. So after this, first of all, we obtain mod a. Mod a is nothing but under root ax square plus ay square. For 3 dimensions, how it can be obtained? For 3 dimensions, this value of mod a will be equal to under root of ax square plus ay square plus az square. Okay. So therefore, r is equal to r naught plus v naught t plus half a t square. The second kinematics equation, velocity given by v is equal to v naught plus a t. That is the first kinematics equation, where v naught is the velocity at time t is equal to 0. So in component form, we can write it like this. Velocity can be written as like this. So now motion in a plane can be treated as a superposition of 2 separate simultaneous one-dimensional motion. So this thing was being explained. So this is nothing but the mathematical form is being written in the written form here along 2 perpendicular directions. Next thing was about projectile motion. So an object that is in flight after being projected is called as a projectile, right? If an object is projected with initial velocity v0, so basically how it is being implemented, let us take this to be x-axis, this to be y-axis. So this is the velocity v0, okay, and this is the angle theta naught, okay. The x-axis, if we assume its initial position to coincide with the origin of the coordinate system, so this is how initial position is being coordinated or coinciding with the origin of the coordinate system. Then the position and the velocity of the projectile at time t are given by, so this, are nothing but derived. So we have derived it, I think, two times on understanding this. So you can just refer back to those lectures and understand how this derivation was being done. So we got x is nothing but equal to v naught cos theta naught t, y is equal to v naught sin theta naught t minus half dt square. Vx is equal to v naught x. So basically the value of Vx at 0 or time t is equal to 0, which is equal to v naught cos theta naught. You can see clearly it is a constant because v naught and theta naught are constant. And then Vy is nothing but equal to v naught sin theta naught minus ut. Okay. Then by simple mathematics, as in removing value of t from the expression of x and t and putting it or substituting it into second equation of y, to obtain the path of projectile of a as to be y is equal to tan theta naught into x minus d by 2 into v naught cos theta naught whole square into x square. Correct? As this is constant and this is constant, this can be written as equal to y into ax plus bx square, which you will understand in subsequent classes of mathematics that this is the equation of a parabola. Okay, so that thing being said, we understood the path of the projectile and we understood the maximum height, that is equal to v naught square by g. Correct? Next thing is this will be 2g. Okay, the next thing was the time taken to reach this height, which was equal to v naught sin theta naught by g. The horizontal distance traveled by projectile from its initial position to the final position it passes at y is equal to 0 during its fall is called as range. And what was this value of range? This value of range was nothing but equal to v naught square sin 2 theta naught by g. Okay, so how were these implemented? So let us say this is the projectile. Okay, so this was the basic height at which the velocity Vy was 0. This is your hm. This is your range. Then the time required from this location to this location is tm, and the time required from this location to this location is basically time of flight, which is tf, right? So tf is nothing but equal to 2v naught sin theta naught by g. And what else can be entered here? So also, what is the maximum value of range? R max is equal to v naught square by g, and when it is obtained, when theta naught is equal to 45. Okay. Also, we understood one more thing, that if we differ by an alpha at both these locations, if this is 45 degrees, then that value is also same for both these projections, which is below and above. Okay, and that value is equal to nothing but v naught square by g into cos 12. Okay, so just you can refer back. I have explained that example also in the projectile motion. Fine. So that thing being said, that the last discussion which was being explained in this lecture was based upon uniform circular motion. So when an object follows a circular path at a constant speed, the motion of the object is called as uniform circular motion. What is the magnitude? Magnitude is AC, which is called as centripetal acceleration, is nothing but equal to v square r. The direction of AC is always towards the center of the circle. Okay, so it is always towards the center of the circle. Okay. Next thing is the direction of AC is always towards the center of the circle. The angular speed omega is the rate of change of angular distance. Okay. So what is omega? It is nothing but delta theta upon delta t. Correct? It is related to velocity v as v is equal to r omega. So we obtained this derivation also, as in why we wrote v is equal to r omega. The next thing was the acceleration is nothing but equal to omega square r. So just putting v is equal to r omega here, we obtained that AC can also be written as equal to omega square r. Okay. Next thing, final discussion was that if capital T is the time period of revolution of the object in a circular motion and nu is its frequency, so this is also called as nu. Then what is omega? Omega is nothing but 2 pi nu or 2 pi by t. Similarly, what is the velocity value? Velocity can be written as 2 pi nu r or 2 pi r by t. And what is AC? AC can be written as equal to 4 pi square nu square. Fine. So that is the end of the lecture, motion in a plane. That is the end of the summary. There's the final course progress. So introduction is done. Scalar and vectors is being done. Multiplication of vectors by real numbers is done. Addition and subtraction of vectors by graphical method is done. Resolution of vectors is done. Vector addition analytical method is done. Motion in a plane is done. Motion in a plane with constant acceleration is being done. Relative velocity in 2 dimensions is being explained. And finally, a discussion about projectile motion and complete ending with uniform circular motion is also complete. Okay. So that being said, that is the end of this lecture. So thank you so much.